Good morning, good afternoon, or good evening. We are talking today about some semi-replicable potential macro PQ effect, and we will focus on the energy and force involved in these events. I'm working in LAPDC, which is a laboratory, private France laboratory. So our focus is to work on macro PKer, or telekinesis or psychokinesis effect on spinning objects. So it's very precise. Our initial target is a plastic cup, like a hemispheric shape, with a plastic plug and needle. So we balance the plastic on the needle and we try to spin the plastic cup. And we can use one, like here, or several stacked up. We work on this topic since 2012 in LAPDC, and for that we make coordination with telekinesis practitioners. We work with other targets like carousel candle or some other objects that practitioners love to find in the house to practice. So, for example, a cake mold. There is two stacked cake mold. A Chinese porcelain bowl on a stem of a candle, carousel, and a metallic bowl, and each with the weight here. So if we look to this kind of target, what are the potential forces in action? The first we look at is mechanical. So mechanical is we make vibration or from a big acoustic wave, and it's pretty easy to avoid it. Then we look to the magnetic, because we use a plastic cup, it's easy to avoid it too. And then we look to electrostatic. So electrostatic, in fact, as we are looking several turns of the object, we eliminate that too, because when you use electrostatics with a body which is static, we don't choose we just move your hand. You are able to make some move in 1/2 turn, and they come back and make a half turn in the other side. But you can't do several turns only with electrostatics if you don't move the generator of static. So in fact, it remains the aerodynamics, thermics effect, which is linked to either airflows in the room that you stopped somewhere, so you disequilibre, and also convection current, which are generated by the thermic of your body, of your hand. So in fact, we work on that and we make more than 500 experiments. When we call experiment, at minimum, it's one practitioner working with a target, trying to run the target with a video control. And we make a series of lab experiments using PI methodology, with the C letter, in order to control and measure the aerodynamics flows around the target. We make some publication in the GSC in 2018 about the methodology, and in a PA journal about the methodology and the results. And in fact, we didn't find any direct explanation of the target spin. The air current, in fact, which was the main explanation candidate, is not good, because in fact the target is running 10 times factors speed quicker than the airflow around. So just to give you some example, I will take one light target which is running very fast. For example, this one. So it's a PKer in a practitioner in Canada. So the target is starting. Then you see that it's moving faster here, depending on your connection of internet. And then, so here we are at 2 seconds, less than 2 seconds per turn. And you can see that at the end, the practitioner is wearing a mask, even if we are not in pandemic, because it was 3 or 4 years ago. So it's avoid breath air on the target. So I will show you another example. This time it's a heavy target. It's 500 grams. So the movement is slower because of the big moment of inertia. And then a little bit quicker. Okay. So these are two examples where the practitioner is making his own video. And then we have the lab experiment techniques. So for that, we use PIV, which calls for particle image velocimetry. In fact, the idea is we generate smoke particles, we see here, and we illuminate these particles with a laser. So in fact, you see the smoke particle. And as the smoke particles are driven by the air, you have, following the particle, the movement of the air. So we use here a camera with image processing, able to compute the speed of the particle, so the speed of the air. So just to show the reference experiment we've done, so we have a boat like a telephone booth, like this. In fact, it's a cabin. Inside it, you have a table. You have the target. You have the laser, which illuminates the target, and you have the camera. And so the camera, which is here, see that, it sees the target, the smoke particles, which represent the airflows, and the hand. And we have another apparatus using directly by practitioner in their home if they want. It's a portable bench. So here it's a plexiglass box with a lid, with a rectangular opening. So we put the target inside the box. We have some incense sticks to generate the smoke. And here the laser is illuminated, a thin slice, which could be horizontal or vertical, in order to compute the speed of the flow around the target. And the practitioner is putting his hand above it in order to drive the target. So the fact that we look at the hand above the target eliminates several explanations which were given in the past. The first one was one of Nekayev, who says that in fact the run of the spin of the target, the paper, was due to the fact that there is a difference of temperature between the palm and the fingertip, and so there is a disequilibrium between the assessing current of air around here, which creates the turn. So that was the explanation of Nekayev. Explanation of Varcollier, the idea was that the body heat create a vertical current, and this vertical air current drive an horizontal current along the table. And when you put in your hand here, you make a disequilibrium of this horizontal air current, and so run the target. And the last one, Hoffman, he thinks that it was in fact the blood pulse in the hand and mainly at the wrist, where you see the vein. And so the blood pulse was able to pulse the target. So you see all this explanation are okay if your hand is at the same level than the target. And in this experiment, the hand is really above the target. So all these explanations are not running. But there is other reasons that did not work. You can work on some light and some kind of target in some kind of environment, but not on this kind of environment. So here we'll see the experiment with 3 stacked cups. So we have 3 cups piled up. So you can see directly, you have one screen, you see the smoke. So the air current, you can see in a different view. So now the target starts to run, you see here. And you see also on the vertical base. And then the speed, you go faster. And so you can see directly. Okay, so this was an example. We have another example with the Chinese. So first you have to success in balance the Chinese ball on the stem. It's not so easy. and then I will show you. So start very slowly because of the inertia, 40 grams. And then you can see the move, the hand, the flow, and you can see also in vertical place. Okay, so this was the lab experiment. And the result of this, so in this experiment, you will compare the reference experiment. So the reference experiment, in fact, we use a pump and we try to start the target. So we try to find the smallest speed of airflow enabled to start the target. And you can compare this minimum speed of flow to the speed of flow when the target is running with a PKer. So I will show you the video. It is very short, so better to explain before. So you see the speed here, and you see the speed here. And the target is running, and the target is running here. And you can see also on the vertical. So you see really the very difference of the speed here and the speed here. And in fact, when we make the measurement with image processing and so forth, we were close to some experiment more than 10 times. So clearly, it was not the airflow which was explaining the run of the target. Now let's go to our main topic, which was, okay, this is working, but what are the energy and forces involved in this? So we use the standard method of evaluation, which are clearly mechanical. So first, the kinetic energy, which is half the moment of inertia multiplied by the rotation speed square of the rotation speed, sorry. So this for the kinetic energy. Then we calculate the torque. So you know when you have to turn something, you have to apply a torque, and the torque is known by the multiplication of the moment of inertia, the same than here, by the acceleration. And then we work on something which anybody knows because we talk about watt. It's the power, which is the difference of energy divided by the difference of the duration during this energy, which is equal to C, the torque, multiplied by the rotational speed. So the first thing is to calculate the moment of inertia. So for example, for the plastic cup, it's a half hollow sphere. So this is the formula. And so you have to know only the radius and the mass. So it's easy. And for the torque, in fact, we use the slope, the gradient of the deceleration curve when we are in a low speed, because above there is also the air frictions. But on low speed, you have mainly the solid frictions. And then when you want to know the total torque, so you have to add the friction torque, just calculate here, with the acceleration torque in order to accelerate the target. And if we want to have an idea about the force implied, we can say that the torque is created by a force applying on the radius on the surface of the target, so at the radius, and so you have the force is torque divided by the radius. So let's go to the first video you see. There's a quick, very fast plastic cup. So the speed was here, and the average speed in red, okay, which gives the max speed, which was 210 degrees per second. And then we have the average acceleration, so between max speed and 0, and the time to reach it. And we have also the max acceleration, which is the acceleration with a steep slope. And we look to the deceleration study. So we take a plastic cup and we launch it at 140 degrees per second, and we look how the speed is going when decelerate. And if we look here, which is below 25 degrees per second, we are close to a line in here. So it's a gradient of the solid frictions. For the cake mold, same approach. We use all the dimension in order to calculate the moment of inertia. And then we use the curve which was a speed up here. And then the practitioner stopped to try to spin the mold, and then there is a deceleration here. And so we are, because it's very heavy, the friction air is not very important. It's mainly solid friction. It's why we have a linear directly from this speed. And so we are able to calculate also the friction couple. We have also the same for the carousel. If you see the video, it was very quick too. You know, that's pretty impressive. And you have the deceleration curve. So we could have directly this. So this was different plateau of speed, and then the deceleration. Same for the metallic ball, for the porcelain ball, Chinese ball. And for the metal ball, we use some software, so we have a better approximation of the curve. And then, sorry for the big tab, we have also by vertical is each target, different target. So for example, here we have one mold, Chinese ball, metallic ball. And here are the different items we are interested with. So the max speed, the kinetic energy, and so forth. So I will go there. So what's important to see is for when we speak about high-end practitioner, it was people who are able to make the highest speed for the light couple, like the first video we saw. For example, here, one cup middle very fast, and we were able to go to 14 microjoule and 0.5 microwatt for the sustaining power. And also when we have a mold, and you are able to be at 40 microjoule, and with the candle carousel, which was very fast, which was at 20 microjoule. So in fact, what is important to see is that with high-end practitioners, we have the same result, the same range of result, if we go with a very light target running fast, or with a heavy target running slow. And max power 0.45 to 1.5 microwatt, which is the power at the end of the max acceleration. If we look to the result about what we get from the lab experiments with the portable bench, we are at 10 to 15 times lower than the best performance because of the confinement. Okay, we are inside the box because of the distance from the target. We saw that the hand is above, and maybe also because we have less number of experiments, so we have less spontaneous success. And also, if we look to what we call standard result, the result we could obtain in normal situation, not best performance, we are close to 15 to 20 times lower than the best performance. So the range is 0.5 microjoule, 2 micronewton for the force, and 0.02 to 0.04 for microwatt, just to have an idea about which kind of number we have. So we could compare that to some other research. So the first research we look at was the one of Norman Hansen and Joshua Lieberman in 2013. We published in GSE. In fact, they use a helmet, above the head, and they look at the torsion of this helmet. So they look at the impact of putting the head here and on the difference of frequency of torsion of this mobile. And they get some first result. And in fact, in Italy, Dr. Antonio Giudetta takes the idea and use the same, but in fact use some plastic plate in torsion, but externally to the people. So people are at 2 meters of these things suspended by a thread, and they look also to the impact to the torsion movement. And they make some calculation, and they publish that they have got to 1,000 to 1/10 of microjoule from a distance of 2 meters. So if we compare to our result, I think it's interesting because it's about 50, at least 50 times more, but we are very close to the target versus here we are at 2 meters. So I think it's important to take into account that. But it's interesting to say that we are around the microjoule. And here is the range for each of the units. So when we speak about sustaining spin power, it's to say that when you have launched the target, how you make of energy power to be able to sustain the movement. Sorry. So the question we can ask after is, are we in the same phenomenon between what we call micro PK today, which is random number generator impact influence? We are in the picronewton here. Here in our experiment, where we could say between 1 to 100 micronewton. And here we could say that we have clearly a distance factor, we have a training and practicing factor, and we have a containment factor. And if we move up in energy, we have some kind of experiment when small objects are levitated. We are looking also to metal bending. And metal bending, if we look to some experiment which was done with Girard in France with the laboratory of Péchinet, they measure around 75 Newton meter, which is really big. And if we move up again, we look at some experiment, some spontaneous events, sorry, with Saint Joseph de Cupertino about his levitation, same for Daniel Douglas Home, and some many physical effects with Palladino or Mathieu, and also many effects about poltergeist. Some effect of poltergeist, some big cupboard of 400 pounds was moved, so you have big energy involved. So is this the same phenomenon? We don't know. I think it's very important to ask ourselves the question. And also what we are looking for too is this telekinesis? So you say telekinesis is we put our body there and maybe in some state, but there is not real intention. You are not able to pilot the move. Or is it really psychokinesis? So you are using your mental to define the move. And we are working today about this question. But today, I think about the community, these questions are pretty important. And it's why we are looking for on future research to work on our side, but with other lab. And today we are looking to study the influence of the distance, the containment, so that if we could discuss later, but about if we close completely the plexiglass box, is not the same thing. And also about the intention. So actually, if you start the target to run, but are you able to stop it and change of sense directly and making some in-lab experiments? So that is the way the things we are working for. And in parallel, we are working on more about documentary work and database about all physical mediumships, poltergeist, and physical effect with mystics. As we see, I think we have to work all these things together to see if it really is the same phenomenon or maybe different phenomenon. So thank you very much for your attention. And maybe now we are open to any questions.